have set up a vector to store y of n. Y is equal to 0, 1 or 20. Then y 1 0 y. Add additional conditions of y minus 2 and y minus 1. Then I have computed the time indexes and then computed time 20 inputting samples of x of n. Then added initial condition of x minus 2 and x minus 1 is equal to 1. Here I have used a y3 equal to for output of y of n, 0 initial condition, and add 0 initial condition of y minus 2, y minus 1. Then compute the time indexes, and then add 0 initial condition of x minus 2 is equal to 0 and x minus 1 is equal to 0, and then output has been obtained, such as this one is for sample of number of samples n part A and number of samples n in part B. We go to next task, which is 12.2. Number of coefficients of h of z and denominator of coefficient h of z have been defined in the start of the code, where numerator is 1 and 1 and denominator is 1 and minus 0.5. Then a step response has been calculated. Our input signal has been defined where n is 0 to 10 time range. The system response and the plotting has been used, and then a stem command has been used for plotting, and title is named as impulse response, step response, and system response. X label is named as n and y label is labeled as y of n. Following is output, where first one is for impulse response, and then is for step response, and then other one is for system response. Moving on to the task 12.3. First of all, I had defined numerator and denominator coefficients, where numerator are 1 and minus 0.5 and denominator are 1.5 and 0.45. Then created transfer function object, then plotted poles and zeros, and then calculated the and plot frequency response. Title is title there, frequency response. This one is our output. The poles and zeros have been plotted, and here is this frequency response and the phase. It is starting from here and terminating here, starting from here and terminating here. Now the next task is 12.5, where I have defined the system coefficients, where the numerator coefficients y and b is equal to 1 and denominator a 1 and minus 0.5. Then set it the sampling rate, which is f as equal to 8000. Then computed the frequency response, number of frequency points n is equal to 1024. Then plotted the magnitude response as we did in the previous codes, and plotted the phase response same as the previous task. This is the output of frequency response and the phase response. The next task is 12.6, where I have defined the numerator and denominator coefficients, plotted magnitude response, plotted phase response, identify the filter based on the frequency response. The following is this code is for identifying the filter type based on frequency response. This is the output of Poisson diagram, magnitude frequency response, and phase frequency response. The next, probably the last task of our lab, which is of task number 12.7. Filter 1 coefficients are numerator 1 0 0 1, denominator 1 is minus 1 minus 1 by 2 and 1 by 3. Filter 2 coefficients are 0 0 1, 1 minus 1 by 2 and minus 1 by 3. Then created transfer function objects. Then plotted poles and zeros for filter 1, poles and zeros for filter 2, and then compared the results. Here the filter 1 poles, zeros and poles, and here in the figure filter, here this one are the poles and zeros of the filter 2. Thank you. This was from lab number 12. Allah Hafiz.